Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad ZULHAKIMI Hakim bin ZAINI and my matrix number is TF22012. Okay, I will present about introduction. The study of pipe networks replicates the pressure-driven constant flow of gas or liquids. Okay, the Hardy-Cross method is the approach that is most frequently used to analyze pipe networks. In fluid dynamics, the Darcy-Weisbach equation ties the average velocity to the substantial head loss or pressure loss caused by fluid friction through a certain length of a pipe. This formula is applicable to fully developed steady incompressible single-phase flows. Okay, next is objective of project. Firstly, to analyze discharge Q needed in every pipe for the water supply system in town A by using Hardy-Cross method with Darcy-Weisbach method. Second, to apply the iterative procedure to the determination of each pipe's head loss and discharge and make algebraic adjustment until Q and dq equal to 0.00 for at least two loops. 3. To determine the discharge and flow direction for all pipe networks.
Hello, my name is ISKANDAR bin RIZAL, DF220084. Today I want to present the problem statement for this project. Problem statement for this project is Q is required in every pipe for this water delivery system in town A according to the discharge analysis using the Hardy-Cross approach with the Darcy-Weisbach method in figure 1. The friction for factor pipeline networks is shown in table 2. Okay, the first purpose for this project is to calculate the discharge Q in each pipe of a town's water supply system using the Hardy-Cross method with the Darcy-Weisbach method used to compute the head loss in the pipes. The analysis should include the pipe layout and attributes such as pipe lines, diameters, roughness coefficients, and elevation difference. The goal is to achieve a balanced flow distribution within the system that conserves mass and energy while minimizing head losses and ensuring an efficient and dependable water supply to the municipality.
Hello, my name is RIZAL CF200232. Okay, for the methodology of this project, in order to obtain the real discharge approach, the Hardy-Cross and Darcy-Weisbach method are utilized to estimate the discharge and pressure in the distribution network with variable pipe diameter, length, and friction factor values. So the first step involves sketching the schematic diagram of the pipe network with constant physical attributes, then followed by mapping the exit and inlet discharge. The pipe was then divided into 4 loops with different characteristics to complete the cycle of the network. After that, the pipe were assigned different symbols such as 3, 4, 5, 6 in Roman, and then the constant K for each pipe was then calculated. Okay, next step is applying the theory of conservation of mass law and utilizing the continuity equation. The analysis forecasted the volume flow rate of each pipe to ensure that the total flow input equal the total flow output. Okay, and then by using Excel, data for each pipe including friction, intake flow rate Q intake, and outflow flow rate Q outflow was entered into Excel spreadsheet. So to get the real result of the flow for each pipe using the friction head loss equation, we need to calculate HF, and the formula is shown in the figure for each pipe, and also total HF while preserving the flow direction sign. After that, calculate N KQ power of N minus 1 for each pipe as well as total N KQ power of N minus 1. So finally determine the value of DQ. The formula is shown in the figure. Okay, that's all from me. Thank you very much.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad SHAMIL bin SHAMSUL. Today I will present about calculation for this project. For trial 1, horizontal flow type, value is 10 liter per second. Vertical flow pipe is 20 liter per second. So we get loop 1, value of this dq is 0.009888708. For loop 2, value of dq is 0.01435417. For loop 3, value of dq is 0.00999,656. For loop 4, value of dq is 0.184161753. Thank you. I will continue about calculation for trial 2. For horizontal flow pipe, value is 5 liter per second. For vertical flow pipe, value is 10 liter per second. So we get loop 1, value of dq is 0.004494354. For loop 2, value of dq is 0.00717721. For loop 3, value of dq is 0.004999828. For loop 4, value of dq is 0.092080088. Thank you. I will continue calculation trial 3. For horizontal flow pipe, value is 3 liter per second. For vertical flow pipe, value is 5 liter per second. So we get loop 1, value of dq is 0.00258,683. For loop 2, value of dq is 0.00401,534. For loop 3, value of dq is 0.002464675. For loop 4, value of dq is 0.273597772. Thank you. I will continue about calculation final. For horizontal flow pipe, value is 0.5 liter per second. For vertical flow pipe, 1 liter per second. So we get loop 1, value of dq is 0.000494435. For loop 2, value of dq is 0.000717772. For loop 3, value of dq is 0.000499983. For loop 4, value of dq is 0.00920809. Thank you.
Okay, so for the conclusion, we solve for pipe networks in loop design using the Hardy cross technique, which entails a series of consecutive estimation and modification to flow in individual pipes. Using Microsoft Excel and the Hardy cross technique, we were able to calculate the flow based on this project. With the Darcy-Weisbach equation and the Hardy cross technique, we will be able to use this project to compute the discharge and flow direction for every pipe in the network. Engineer must thus accept responsibility for their work since everyone benefits greatly from it. Finally, we hope that our research will be beneficial to both future engineers and other people. Okay, that's all from me. Thank you.
At the last, I want to thank Dr. SITI HIDAYAH and also the crew members for good working and hard working. I'm going to say thank you, guys. See you later in different chapters. Bye bye.